Okay, welcome back. The second part of this section is for problems where you have 4 or more terms. There are usually other ways that we can solve them that are more direct. It's a little weird to look at, but basically let's see it and then I'll talk about it. So it's called factoring by grouping, which means you're going to group things into 2 or 3s and find out what they have in common, and then consider turning them into factors. So factoring by grouping is the use of the distributive property, still using that same concept that we used above, to factor polynomials that have 4 or more terms. So if they have 4 or more, you've got to think it's probably factoring by grouping. These can be factored by grouping only if all of these are true. So we're going to write what has to be true for using this method of factoring by grouping. Okay, so we've said this one already, but there are 4 or more terms. Have to be at least 4. The terms have common factors that can be grouped together. Maybe. Oh, I see. So we're going to group things and see if they have common factors and make sure that the remaining pieces match. Then there's the matching part is that there's 2 common factors that are identical, or they may be additive inverses of each other, which means that we could pull out a -1 and they would still be they would then become the same if they're additive inverses. So I wanted to show you an example here of, let me slide this up just a little bit, of what an additive inverse looks like. So an additive inverse, and I just kind of wrote this on the bottom of my notes, additive inverse. So if we, for example, have, I think I'll just do it this way, a plus b. That is a factor. It's in parentheses. It's going to be the polynomial part of it pulling out of a GCF, like we had above, like this. So this is the polynomial. Maybe we have an a plus b left after we pull out a common factor. The additive inverse of a plus b is you take what is there and you make the signs opposite. So the additive inverse of a plus b is just -a minus b. Okay, let's do another one. The additive inverse of -b plus c, we change the signs. So b is negative, it's going to be positive. C is positive, we're going to make it negative. It'll be b minus c. So you have to watch for those and see if they're not identical, if maybe you can pull out a -1 and change something into, like you might get -b plus c and your other factor is b minus c. So you can make it into a b minus c. Okay? So let's move forward and talk about this factor by grouping. Alright, so we're going to we're going to group things. So let me see if I can add a text box over here. I just want a regular text box. No, not what I want. Over here. Oh, I see. I'm just not paying attention. Okay, so here we go. We can, first of all, group sets of 2, or if you have more, it could be 3. But I think all the ones that we're going to do will probably be sets of 2. So here, we're going to take this first thing, and we're going to just say, I'm going to group these 2 together, and I'm going to group the second set of 2 together. So that's my grouping. I'm going to group 4QR and 8R, and I'm going to group 3Q and 6. And it doesn't matter if it's factorable by grouping. You can literally pair any 2 together and you will still make it to the right answer. There's not a right or wrong thing to choose, but a lot of times they're going to lay it out for you in such a way that the first 2 work together and the last 2 work together. Okay, so then you're going to consider each pair separately and pull out the GCF just like we did in the first section. Okay, so we have to do 4QR, 4QR equals something, and 8R equals something, and find the GCF of those. And then we're going to do the same thing for the other sets and say 3Q equals something, 6 equals something, and they have a GCF. And we're going to look at each one separately. So I'm going to try and put these in 2 columns so we can see them at the same time. Oh, here, layout, sorry. 2. There we go. Okay, so 4QR breaks down to 4 is 2 times 2, and then we have a Q and an R. 8R, we did it earlier, 8 is 4 times 2, and 4 is 2 times 2. So we're going to do 2 times 4, or 2 times 2, and times R. So the GCF of these 2, if we circle what's in common, we've got some 2's here, and we've got, what else? The R's. Okay, so you have a 2 and an R as your GCF. So what does that mean here? Our polynomial and monomial mix here will be 2R times what's remaining. The 4QR has a 2 and a Q left. 2Q. The 8R has 2 times 2 left, so that'll be a 4. Wait. We made a mistake. I missed something, didn't I? I missed one of the 2's. So you might have been trying to yell at me through the screen and say, Mrs. Bruce, I need to circle another set of 2's. Here we go. So we have 2 sets of 2's. So it's 2 times 2 times R, or 4R. So let's start that again. So now that I've circled the right things, 4R, the 4QR only leaves a Q, and the 8R only has a 2 left over. So that's the first part of our equation. We have to come over here and do these as well so that we can write the next part, which will be made up of the 3Q plus 6. So 3q here is nice and easy. It's just 3 times q. 6 is just 2 times 3. And for some reason, 2 times 3. I wrote plus, but I meant multiply. So 3q is 3 times q. 6 is 2 times 3. What do they have in common? We will insert our circle, maybe, to cover up those 3's. And our GCF is only going to be that number 3. So if we come over here and continue our polynomial, our GCF of the second set is just 3. And what is left, 3q is q, and left in the 6 is a 2. So this is what we want. We're going to consider each pair separately, pull out the GCF. I didn't write the next step down, so I apologize. You will write the write the monomial and polynomial pairs, just like we did in the first part of the section, but now we have 2 because we grouped 2 different things together. We had the first 2 terms and the second 2 terms, second pair of terms. And then we write the outside terms as one factor and the identical terms as a second factor. So let me explain what those are going to look like. I thought that might do that. Oh boy. Let me slide this over so it doesn't mess with my columns. Okay. So here we have this. We have q plus 2. That is the identical terms. Both of these pairs gave us a q plus 2. So we're going to write so what our answer is going to look like is a pair of parentheses with something plus something, and the second part, why is this not working? Okay, let's just write it then. Okay, so it says write the outside terms as one factor. So what I mean by outside terms is this 4r, no, just the 4r, and okay, well, let me do it. So the 4r is an outside term because it's outside of the parentheses, and the 3 is an outside term because it's outside of the parentheses. Then write the identical terms as the second factor. So q plus 2 is my second factor. So each of these sets of parentheses is called a factor. A lot of the times problems we work with are only going to have 2, but that doesn't mean they can only have 2. It can have many different combinations of factors, which you'll get into as you get into the higher level math. But right now, just know that this set of parentheses is a factor and this is a factor. When we were working above and it was a monomial, like just the 4r plus q plus 2, this is a factor, 4r, and q plus 2 is a factor. But when we are grouping, our factors have to be 2 sets of parentheses. Okay, so let's look at another problem. We have 4 terms, so that means we're going to factor by grouping. And, uh-oh, that didn't like that. Alright, well, what's done is done. So we'll come down here and look at this one. So we're going to combine these two. Oh dear. So let's go ahead and just, maybe we'll do this. Nah, I don't want to do that. So we're going to do Rn as one factor. And we're going to pair that with 5n. And we're going to find the GCF there. And we'll do the same thing for negative r and negative 5. And we will find the GCF of those. Alright, so Rn, nice and easy, is just R times n. 5n is just 5 times n. So what do those have in common? It's just going to be the n. Okay, then when we come down here, negative r would be negative 1 times r, and negative 5 is going to be negative 1 times 5 times 5. So these have a negative 1 in common, and that is it. Alright. And you can figure that out with your circles. But I'm trying to save time, maybe. So here, what's in common? N. And circle, what's in common here is my negative 1. Okay, so we figure all that out. Bear with me for 1 second. I've got to go get my cord. Okay. Now the entire computer won't die, hopefully. Okay. So we're ready. I'm gonna put these up here next to each other so we have room to work. I should have done that first. Never mind. Let's do this. Alright, so we're ready to put things together. So my first group of things, the GCF, was N. And what was remaining, Rn, just has an R. And then plus 5n was just left with a 5. Okay, then we're going to do the second set of terms. What did they have in common? That was a negative 1. And what was left in those? The negative r still has an r, and the negative 5 still has a 5. So if we look at these, you got to say, what do they have in common? R plus 5. So that's my second set of factors. The first set of factors will be n, and then we have plus a negative 1, so you can write plus a negative 1, or you can just write minus 1. That's my first factor, my outside terms, and then we'll have r plus 5. So this is your answer right here. and start putting those in green. That's my final answer. And if you went and FOILed that out, you would get this as your original equation. We would get first, or r times n, see outside, or 5 times n, inside, or negative 1r, and last, negative 1 times 5 is negative 5. So that is correct. Oh, excuse me. Okay, moving on. Special case. What if we have these additive inverses? Okay, so we're going to start with the same kind of thing. We are going to, the process here always starts the same. We're going to start by finding our GCFs. I'm going to pair 2mk and 12m, and I'm going to pair 42 and negative 7k. So 2mk, I've got to find that prime factorization. Minus 12m, I've got to find that prime factorization and come up with the GCF. And then I will look at my second pair of things and do 42 and negative 7k and find out that's GCF. Okay, so 2mk is nice and easy. That is just 2 times m times k. Sorry, lowercase. Okay, negative 12m, so I've got a negative 1. Factor tree for 12 would be 3 and 4. So let's come into my PDF and slide down. Here we go. So if I have to make a factor tree, here's the problem. Here, and we'll do this for a couple of them. So 12 is 3 times 4 and 2 times 2. So we've got a 2, a 2, and a 3, and the negative 1. So negative 1 times 2 times 2 times 3, and variables, I have an m. So what of these things are in common? So let's go ahead and expand this one over. I've got a 2 and an m. So if I circle the 2 and the m, that will become my GCF. And I can see what's left over. Okay, so my GCF here will be 2m. My 2mk will have a k left over, and my 12m will have all these numbers left over. Alright, for my second set, 42, I've got to factor tree that. So 42 is the most common fact you would come up with would be 6 times 7, and 6 is made up of a 2 and a 3. So we have a 2, a 3, and a 7. Okay, 2 times 3 times 7. Negative 7k, negative 7, so we got to pull out the negative 1, the 7, and it just has a variable of k. So what is in common between these two? 2 and 3 are not down here. The only thing is this 7. Maybe. So we've got a 7 here. Everything that's not covered up will become our polynomial. So our GCF here is just 7. So let's try and start writing our factors. So the first set, the GCF was 2m. The remaining things from 2mk, I used this and this, I've got a k left over. So that's k plus negative 12m, I've got a negative 1 times 2 times 3. So that is negative 6. So let's actually write that as minus 6. Okay, then my next set, my common factor here was a 7. Then I have 2 times 3, or 6, And what's left here? Negative 1 and k, so minus k. So our hope with these is always that this piece and this piece will be identical, but they're not here. So what we have to do is say, okay, fine, I'm going to rewrite one of them so that it looks like the other. So I'm going to say, I'm going to check and see if 6 minus k is an additive inverse here. So I'm going to multiply negative 1 times 6 minus k and see if that is my other term. So when I distribute here, negative 1 times 6 is negative 6. Negative 1 times negative k, well, that's plus k. The other side is k minus 6. So is negative 6 plus k the same? Yes, I can reorder in addition, so it's k minus 6. So we have to go and take 6 minus k and rewrite it as that negative 1 times. Okay, so let's not say this, let's say test. Negative 1 times 6 minus k is in fact k minus 6. So we're going to pull a negative 1 out of this and put it in front of the 7. We're going to move it from the 6 minus k to the 7. Okay, so we'll get 2m times k minus 6. That's still the same. We like the way that one looks. Plus 7 times negative 1. And